Hey everybody, sure do miss y'all. Let's see, today we're going to approximate the area under a curve using the trapezoidal rule. Yesterday we used Riemann sums, which is where we would draw rectangles underneath the curve, and we could see how that approximated the area. It didn't give us the exact area. So what I'm going to do today, this is the same problem we did yesterday. It's example 2. But this time we're going to approximate the antiderivative of f of x dx, in other words, the area under that curve, using the trapezoidal rule. So we're going to draw trapezoids instead of rectangles. So let's recall real quickly, the area of a trapezoid is 1/2 the height times the sum of the two bases. So to remember what a trapezoid is, I'll just sketch one real quickly. This might be a trapezoid. So your height is always perpendicular to your two bases, and your two bases are the two sides that are parallel. All right, so now what I'm going to do is I'll sketch just a few of these points just so you can get the idea of what we're doing. But again, sketching is not necessary in order to figure this out. This is just so you can picture what we're doing. So just a quick sketch of just the first, I don't know, 3 points on here. So we've got 0, 2, and 5 are our first values of x values. 0 goes to 4. I'm just going to put 3 points here. So 4, 8, 16. So 0, we have a point of 4. At 2, we have a point of 6, which would be halfway between 4 and 8. And 5, we're up here at 16. And then we could continue to draw that, but that would be a waste of time. There's no need to do that. So now, instead of drawing rectangles going from one to the other, we're actually going to draw trapezoids. So again, I'm going to draw these vertical lines that go from the x value to its corresponding y value. And then I'm just going to connect the dots up here with nice lines instead of making it a curve. So you can see how these trapezoids are formed. So this is trapezoid 1, here's trapezoid 2. Okay, so I'm going to make a chart like I did yesterday. First of all, the distance between these x's, that's going to be the height of your trapezoid, because that's the side that's perpendicular to the two parallel sides. So the y values are going to be our bases. The y values are our bases. The distance between our x value, that's our height, because those are perpendicular. So notice the distance from your one y value to the other, from one point to the other, that's not written in the formula. We don't need that. All right, so I'm going to make a chart like I did yesterday. I'm going to have the interval, int for interval, the height, the sum of the bases, we'll go ahead and do that, sum of the bases, and then we can find the area of our trapezoid. So our first interval is from 0 to 2, and again that distance gives us the height of our trapezoid, so that distance is 2. Sum of the bases, all right, if we're going from 0 to 2, then this base has a length of 4, this base has a length of 6, and we can find that in the chart. So we're adding the 4 plus the 6. So we're taking 1/2 of 2 times 10, so that's just going to be 10. Our second interval goes from 2 to 5. Well, now that distance is 3. So just like with the Riemann sum, these x values do not have to be equidistant. They don't have to be the same distance apart. All right, so for this interval, our bases are the y values at 2 and at 5. So that's going to be 6 and 16. And we can see that from the chart. 6 plus 16. So now we're taking half of 3 times 22, and that's going to be 33. Our next interval, and now we don't have this drawn, but we can figure everything out, goes from 5 to 11. Well, that's a distance of 6. The y value at 5 is 16, so that's the height, or actually the base. And then at 11, the y value is 18. So 1/2 of 6 times 34 is 102. If you don't believe me, do it on your calculator. Our next interval is from 11 to 19. That distance is 8. Our y value at 11 is 18. That becomes one base. Our y value at 19 is 22. 1/2 of 8 times 40 is going to be 160. From 19 to 22 is our next interval. That's a length of 3. The y value at 19 is 22. The y value at 22 is 29. So now we're going to do 1/2 of 3 times 51. So this is our first one that's not going to be an integer, but that's going to be 153 over 2, and I'm actually going to write that as 176.5. And then finally from 22 to 23, that's a distance of 1. The y value at 22 is 29. Y value at 23 is 50. So we're taking 1/2 of 1 times 79, so that's just 79 halves, which is 39.5. So when we add all these up, we get an approximation of 421 for the area under that curve. Now yesterday we did the same problem with rectangles. We did a Riemann sum. Let's see, yesterday we did, I believe, I think we did left hand. But the answer we got yesterday was 361, and actually 421 is a little bit better approximation. Now, if we knew the actual formula for f of x, then we could just use our fundamental theorem of calculus, take the antiderivative, plug in our values, and we'd have the actual area. But since we only have a chart, then this is how we're going to do it. Now, there are some shortcuts for this. I don't ever use them. I like to always just draw it out, because notice you've got these numbers repeating themselves, the 6, the 16, the 18, the 22, the 29. So if you want to look in your book and actually see some shortcut formulas, that's fine. But to me, this way I always understand what I'm doing. I actually think about the trapezoid themselves to get this final answer. So yesterday on your worksheet, I had you only do the problems that had to do with Riemann sums. So today you're going to go back and do the problems that deal with the trapezoidal rule. And then there's still one problem we're skipping where you do actually have the formula for f of x. We'll go over that tomorrow. All right, thanks y'all. Bye.